Good morning, good afternoon, and good evening to all of our friends from around the world. We are live right now. This is the .NET Doc Show, and we're here with a special guest today, our good friend all the way from out east, Jon Skeet. Jon, good morning. Hey. Good afternoon.
Nice to be with you.
We're thrilled to have you. We're super excited because today we are not technically supposed to be working. It's a holiday for us, and we decided we would try something different. And we shifted our schedule around. We recently, I don't know if you know this, Jon, but we recently just got adopted into the official .NET branding. So now we're part of.
Woohoo!
Yeah, we're official. We've made it, right? So, and now you're here with us, and we get to geek out about one of your personal favorites, DateTime stuff.
Yep.
So cool. Why don't you let the world know who you are?
So, my name's Jon Skeet. I'm a software engineer based in Reading, which is just to the west of London. I work for Google on the .NET client libraries for Google APIs, particularly Google Cloud APIs. I've been with Google for about 12 years, thoroughly enjoying it. Outside work, I am the main contributor to the DateTime API that we'll be talking about a lot today. And people might just know me from Stack Overflow, where I've written quite a few answers, or possibly from a book I've written called C# In Depth, which is currently in its 4th edition. And I'm feeling increasingly guilty about the fact that I haven't got an edition that covers C# 8 yet.
So we were commenting before the show, and I imagine a lot of our guests probably relate to this feeling. I'm a little kind of starstruck sitting in a city and hearing a chat with Jon Skeet. I can think back years ago, when I first started my Stack Overflow account. I'm like, oh, I'm going to get on Stack Overflow, and I'm gonna be the guy that answers all the questions. And it seems like they were all already answered by this Jon Skeet, right? So I unfortunately I'm relegated to just a mediocre commenter, apparently.
Now, I think what you'll discover is a sense of disappointment over the next 50 minutes that I'm really just not that smart. But there we go. Yeah, we'll let that play out.
Oh, well, compared to us, you're like a genius, so it's fine.
Nah.
No, that's awesome. Yeah, I was asking Jon just before we went live. I'd asked him, hey, it's your evening. Have you answered any questions yet today on Stack Overflow? And he's like, nope, just commented. I answered one yesterday, and that's probably more than most people have answered holistically. I remember earlier in my career, I had set out for like this personal goal, and I was like, I'm going to answer a question every single day, and I failed miserably. It's very difficult to do. And one of our friends here in the chat is asking or stating rather rhetorically, there are DateTime bugs. Yeah, I think there's a couple.
Well, if we think we've finished with everything about DateTime, halfway through the stream, we could always go on to versioning. That's my other pet topic.
Ah, yes.
So,
Cool. We're going to jump into the checkup right away, and we'll see you guys in a second. So being that our theme is DateTime bugs, our checkup doc for today is going to be the string interpolation C# reference doc, which I have pulled up here. And there's been a few recent changes to the IDE, which have actually empowered some IntelliSense specific to date times. So if you recall, prior to C# 6, formatting strings was ordinal based. And Jon, feel free to jump in here and just slap me around with your C# knowledge.
It's all sounding good so far.
But yeah, with C# 6, they introduced string interpolation. And essentially what that allows you to do is you start a string with the $, and then your double quotes, and then your string can now be interpolated such that within these squiggly braces, you can introduce actual variables. And those variables will essentially call into the toString of that object. And you can actually take it a bit further. And let's see here. We've got a Razor page, and this is jumping over into Visual Studio proper. And I wanted to show you real quick. This is actually our site, the .NETDocs.dev website. And we've got some binding here where we walk up to our DateTime value and we call format showed show date, and we've got our DateTime object, and we're doing string interpolation, and we've got our date object. And when we do this, we can actually get IntelliSense now. So if we were just to leave this as such, it would use the default DateTime instances to string. But if we do semicolon here and start typing, we actually get IntelliSense. And this is what we wanted to show off, is the fact that we get statement completion telling you exactly what these different things are. Because I cannot tell you how many times I've personally had to Google, with Bing, of course, how to format a DateTime and what the different monikers were. So what's the capital M versus the little m, and what does D do, and what's big D versus small d, and F, and all these great things, right? So yeah, it's great. It's an improvement, and I hope that all the developers around the world will find it, use it, and enjoy it. I think that's all I've got for that. Is there any...
One last thing, David. I may have missed this, but did you mention which version of Visual Studio provides that IntelliSense that you were showing off?
That's actually a good question. I think that's the 16.7. So Visual Studio 2019 version 16.7.
Yep.
Do you know what would be really nice as a feature enhancement, specifically for DateTime? If you've got a string interpolation at the moment, wouldn't it be lovely if it could give you a preview of this is what that would format to just now? Ah,
yes. Yeah, that'd be pretty
date and time is something we've always got an example of what is the current date and time.
I love that idea. It's sort of like a dry run or a what if option, as if you were using a command line tool.
Yeah.
So to your point, you'd have something here. So like essentially once you start kind of doing your magical whatever, so like this though, or no, this is just showing the month.
So that's so if you have the interpolation and you keep typing, could it show in? I'm not a UI person, but it feels like there should be somewhere that it can have. You've got MMM, DD, YYY, HHMM in the format show date one. How about it could just format all of it? Oh, it does. It does.
No.
Woohoo.
Oh, but I think that's just the H or the YY. So look at. So I think it was cheating a bit. Or no.
So,
no, it's not.
To the tooltip there.
You're right.
See
it's not. No, John's right. Look at. So we do MM, M, DD. If I do a comma and I do YYY,
yeah,
it's going to show. Yeah, it's showing all of it. You're totally right. It's doing that.
That's really good. Yeah.
So basically, your idea, we just implemented it live, and we can.
Right. Come
part of the product.
Anyone who wants me to, just say, wouldn't it be nice if, and we'll see what we can get done. We've got 50 minutes. How much can we get done in Visual Studio quickly?
That's a great segue to jump right into our hallway track, which is our favorite part of the show. So the hallway track has always been our favorite. Since we started doing this back in February, when we first started our show, we slowly evolved into kind of getting this idea around, everyone's kind of virtual now. And one of the favorite things that we enjoyed personally as developers and attending and speaking at conferences was the hallway track and some of those great conversations. So this is our attempt at that. And it's our favorite segment of the show. And again, we're very excited to have Jon here today. And the idea, when I first reached out to Jon, I said, maybe we could just totally go into our source code and hack it and push things live to production. But I think there's a lot of things that we have to discuss before we start doing that. I mean, we've got a live share actually opened up now with Jon, which is cool. And I've got my screen share here. But yeah, let's, I guess, start talking first about date times and how scary they can be and some of the problems with them.
Yeah. So in fact, I tend to, I have a conference talk that's got a title of something like working with date times, difficult but not impossible. I tend to feel that developers veer in one of two directions, but too far. Either they think it's fine, I don't need to think about it much, it'll just do the right thing, and then if you're lucky, it does the wrong thing immediately, and you can find that out. If you're unlucky, well, I suspect there's an awful lot of code that works throughout the year apart from 2 hours. And those 2 hours are when there are very few users, so you can have a bug in production for years and not know. And okay, arguably then it's not a very serious bug, but it could potentially do something serious at some point. So either they're completely blasé about it, or they say to themselves, time zones are just so hard to comprehend that I kind of won't bother. I won't try to get over that hill. And my point is really that it is feasible. It's tricky. There are corner cases, and I go as far as time zones and calendar systems are comprehensible. Leap seconds, just no. Let's just not go there.
Wait a second. What's a leap second? What does that? What does that even mean?
Oh. So a leap second is inserted sometimes into our time system when the Earth has been rotating either a bit too slow or a bit too fast. I can't remember which way round it is, so that a year isn't exactly as long as we would like it to be. And so in theory, I think theoretically, but not in practice yet so far, a minute can have up to 62 seconds. Realistically, we do have leap seconds every so often, so a minute can have 61 seconds. But almost no business software needs to cope with it. And so DateTime in particular doesn't even try. .NET, I believe, doesn't unless you opt into it and you're using a particularly recent build. The things have been happening in the Windows space to enable leap seconds. I tend to just shut my ears and la 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 la, or just break down and cry. It's too hard to think about them. And there are various different sort of timelines that you can have that do or don't include leap seconds. There's TAI 1, TAI 2, TAI 0. UTC is sort of its own timeline in that front. But yeah, the details of it baffle me, so I try to ignore it.
So someone's asking here in the chat, is leap second forwards or backwards?
So it's like a leap day. So it's really annoying. We talk about leap years as a year that contains an extra day. But really we should talk about a leap day. So February 29th is a leap day when it occurs. The Hebrew calendar system has the idea of a leap month, so that some years have 13 months and some have 12 months. And a leap second is like a leap day. It's an extra thing at the end of its container. So the container for a day is a month. So a leap day is an extra day at the end of February. A leap second is an extra second within a minute. So I think they're done at the end of a day. So you would get, the time would go 23:59:58. 23:59:59, 23:59:60, then 00:00:00 as for the next day. Yeah, and the comments about an extra month, let me just blow your minds just a bit, and then we'll get down to slightly simpler things. So the Hebrew calendar system sometimes has 12 months, sometimes 13, and it's the month Adar. I believe it's pronounced Adar. Apologies to any Jewish friends or anyone else observing the Hebrew calendar system if I'm mispronouncing this. But the month Adar becomes Adar 1 and Adar 2 if you're in a leap year. And it gets really odd when you think about about how old people are. So suppose we were born, say Cam, just as an example. Suppose we were born in the same year, which is a leap year, and suppose I was born on the 20th of Adar 1, and you were born on the 10th of Adar 2. Okay, so I was born before you. I'm older than you, right? All sounds fine so far.
Okay.
Now let's go into a non-leap year where there's just Adar. Then you would celebrate your birthday on the 10th of Adar, and I would celebrate my birthday on the 20th of Adar. So you would be celebrating your birthday 10 days before me, even though I'm older than you.
What? Oh God, that's cool. That's not cool.
It's just
I'm hearing brains explode all throughout the audience here, mine included.
Fortunately, that doesn't have to have too much impact on most systems. Don't need to know about calendar systems other than the Gregorian calendar, which is the one we're all familiar with.
So that's really interesting though. Like just double clicking into that. So if there's just no Adar 1 or 2 and the following year is a non-leap year, and so it's just Adar, like how would a date time structure know to represent that? Like how does it know? Like Cam's got a calendar, imagine an Outlook, for example, or Google Calendar,
Right.
whatever it is. He's got a reminder of when his birthday is, or his wife does, right?
Right.
How would it know when that is?
So it would have to know what the rules are. So it would have to know that the date of birth, that the number, and I can't even remember. It doesn't help that there are 2 different numbering systems for the Hebrew calendar system, the sort of civil one and the scriptural one, and they have different idiosyncrasies. But if you knew when you were born, then the calendar can display this is in Adar 1, this is in Adar 2, and I would expect it to know if you have an annual event, so something that occurs every year in Adar 1 or Adar 2, that should occur in Adar. Now, if you start the other way round, if you were born in a non-leap year in Adar, I can't remember whether you then celebrate your birthday in Adar 1 or Adar 2. And I will now find the I haven't asked many questions in the Judaism Stack Exchange, but I have asked about Adar 1 and Adar 2, and I believe that I saw somewhere that because I think there is a bug in .NET here that
Just one bug.
The second Adar is the real Adar, according to some piece of scripture. And so calendar.isLeap month in .NET returns true for Adar 2 when I think it should return true for Adar 1. I'm just going to pop that link in the chat.
Perfect.
Just for fun. I would put it in the comments. I don't appear to have the ability to put it into the comments.
You can
I put it in the private chat and then
I sent it. Ta-da. We'll show it.
And
there it is. It's on screen now.
My other one as well for how do you add a year? So literally, the what do you do about birthdays? Because I needed to know this to get DateTime to do the right thing.
Right.
Oh wait, so let's take a step back real quick here. You just mentioned DateTime, and we haven't said anything about that yet. And I do apologize. That's part of. I mean, what is DateTime? What is this thing?
So, why don't I take us on the story of how it came about, and that will make it obvious. So, when Stack Overflow started, I think it was in 2008 that there was the first developer days, dev days, Stack Overflow sort of conferences around the world, and they were really cheap, partly because I think they didn't include food. So it was come to a one-day conference for $20 or something like that. And it was sufficiently into the me being in Stack Overflow that I was known by then. So I was asked whether I would like to give a talk, and I said yes. And somebody in MetaStack Exchange said, why don't you do it with a sock puppet? So I decided I would. And I can't remember how I got the topic, but basically I decided to speak about humanity epic fail, how we can blame everything that's gone wrong on all kinds of people. So I looked at numbers and text and dates and times. They're sort of the three most basic building blocks of data. And went through, in every case, humanity through evolution has, through cultural evolution, has made things hard, and systems architects have made things harder still, and then software engineers have made things even worse. So I just blame lots of people for everything. It's a fun talk, and I still give it occasionally, because strangely enough, the world hasn't become that much better in terms of how we handle fundamental data types. But near the end, one of the things I say is, okay, don't get too scared about it. Try to do some research, find out how much you need to know for your particular situation. So, if you're writing an application, does it need to handle multiple calendar systems or not, for example? And then use the right tools for the job. And for Java, for date and time stuff, I was able to say, hey, use DateTime, because back then there was no java.time package. It was just DateTime was far and away the thing to use, and everyone was using it. And then I had to say, for .NET, there isn't anything. And I think within a week or two, I was feeling so guilty about .NET being the platform that I love, really not having what I consider a good date and time API. And I thought I had to do something about it. So I started off by kind of porting DateTime and fixing some of what I viewed as the API mistakes as I went along. As it happens, I ported the sort of engine behind the scenes fairly verbatim, but kept it all internal, and then put a slightly nicer, in my view, public API to wrap it. And then a couple of years later, I think, I then rewrote the underlying bit that, fortunately, because I kept internal, I was able to do that without any public API changes, and simplify that, because it was really, really complicated in DateTime. So yes, what we've ended up with is a .NET library NuGet package for handling date and time in what I believe to be a clearer, more or less error-prone way. The other reason that you might want to use it beyond sort of I want to write clear code is it includes and has good support for the IANA time zone database, which is the set of time zones that everyone apart from Windows uses. So if you ever see time zone identifiers of something like Europe/London or America/New_York, etc., those are IANA time zone IDs, and also known as the Olson time zone database, also known as just TZ. We call it TZDB in DateTime. I would call it IANA, but when I started writing it, IANA hadn't taken control of it, as it were. So yeah, we've got a fairly popular, it's Node.json.NET. Equally, it is reasonably widely used, I believe.
So this is an interesting trend that I've noticed as I've used different languages and worked in different developer ecosystems. For example, if you take JavaScript, you've got libraries like Moment.js and Luxon that handle the shortcomings in the DateTime APIs. I wonder, are there other developer ecosystems outside of JavaScript and .NET where the same problems exist?
Oh, absolutely. I think almost every ecosystem, the fundamental platform doesn't do quite the right thing. And I believe it's getting better in JavaScript. Certainly Java was awful. And I sort of dislike the fact that DateTime in .NET is really quite easy to use, which makes it not obvious to start with that it's kind of broken. Whereas in Java, you had Java util calendar and Java util date, and they were just absolutely hideous. And it was so obvious that we needed something better that when DateTime came along, it was like everyone flocked to it. Whereas a lot of people will, understandably, I'll say understandably more than reasonably, because I think it is, understandably, people say, I don't want to learn DateTime. I've got stuff working with DateTime already. It's all fine. Now, I would argue, yes, there's a bit of a hill to climb in terms of learning a new API. Then everyone who reads your code needs to know the API, etc. I would hope that your code becomes so much easier to read and write, and it's more obviously correct, that it's worth that price. Obviously, there's no monetary price; it's an open source library. But yeah, I don't know of any ecosystems at the moment that just got date and time right to start with. I think Go is fairly reasonable, and various things have got better out of the box as time goes on. I've said several times, if Microsoft ever wanted to just put something like Node Time into .NET Core, and I could just stop maintaining Node Time, or just do patches where necessary, I would be absolutely fine with that. My ambition is not to write date and time APIs; it's to make sure there is a good date and time API out there. So the whole sort of embrace, extend and extinguish, I kind of, yes, please. I'm really up for that. I've got other stuff I can be doing. But
like answering questions on Stack Overflow.
Well, I think it would be writing versioning tools. But we'll come to that another time.
So, John, something you just mentioned made me think of another question. Is Node Time part of the .NET Foundation? And if so, what benefits have you realized?
It is
becoming
not
a member.
It is not at the moment. I, having recently retired as a board of directors director, as it were, from the .NET Foundation, obviously I have nothing against the foundation whatsoever. It's mostly a matter of, well, it's kind of hassle to submit the project, and we're kind of okay where we are. It's not like Node Time requires a huge number of servers or whatever. So there would be relatively little benefits for me at the moment. There was a time where the foundation was discussing a maturity model, which this may now spark flame wars in the comments, and I really don't want it to. But the maturity model would have given some benefit to Node Time joining the foundation and then being certified at a certain maturity level, so that then Microsoft could depend on it in ASP.NET Core, for example, and other people would feel better about depending on it. I'm certainly not saying it won't happen, but it hasn't happened yet.
I mean, out of curiosity, being that .NET is open source, have you ever considered just doing like incremental PRs to slowly introduce some of this core functionality into the runtime?
So, for one thing, I think me contributing to PRs to .NET itself may be quite tricky in terms of working for Google, and I need to get various approvals and things. There's bureaucracy involved. But more importantly, trying to modify the existing system.datetime or datetime offset to be better, it wouldn't really work. So aside from there's huge amounts of compatibility to keep, there's the addition of, it's just the wrong model. DateTime, I've got a blog post about what's wrong with DateTime anyway, which I will again link to.
Yeah, pull that link up. And there was a question earlier, or someone had stated that they use date UTC all the time.
Yeah, I was looking forward to talking about that.
I was great segue.
So that's, I've posted a link to the Node Time blog about what's wrong with DateTime, and now I'll find the other blog that I refer to reasonably often, which is UTC is not a silver bullet.
And then also, in addition to that, there's a DateTime versus DateTime offset question as well.
Yes, and I tend to end up finding that quite a tricky one to answer, because quite often I want something that's neither of them. So hopefully there'll be a link for the storing UTC is not a silver bullet. In many places, using UTC is fine. In other places, particularly when you're talking about a future event, then it's asserting you have more information than you really do. but then so is using DateTime offset. In general, I would say, this sounds like a truism. If you have a DateTime and an offset from UTC, you should use DateTime offset. And that offset from UTC may be 0. So if you have a timestamp, I would typically represent timestamps in plain.net as a DateTime offset. Because then I don't need to worry when I'm reading it. I don't need to think, well, is that actually a local one, an unspecified one, or a universal one? And this is really my big beef with DateTime. Can you imagine, instead of having int and double and decimal, suppose we just have one struct called number in .NET, and it had a kind which said, this is a floating point or an int or a decimal. And I should say a binary floating point, because decimal is also floating point. And, doing the right thing meant that you needed to know what kind of number you were looking at to start with.
That would be terrible.
It would be awful, wouldn't it?
It would be terrible, yeah.
But that's exactly what we've got with DateTime. And we even didn't have the kind property before .NET 2. So it used to be that if you called datetime.now.toUniversalTime.toUniversalTime.toUniversalTime, it would keep on converting it, assuming, this must be a local one. Yeah. So it was just badness. So things were added in .NET 2, which kind of made things better in a way, but made it clearer that the abstraction was wrong. So in NodaTime, we have a local DateTime, which isn't quite the same as local. In datetime.kind of local means it's in the same time zone as the system, the computer system you're running on, which is a kind of weird thing, particularly for server systems. Like, why do I care what time zone my server is in? I really shouldn't. So there's a local DateTime. This is a date and time with no time zone at all, and that's the equivalent of datetime.unspecified. There's an offset DateTime, which is equivalent to DateTime offset. So here's a local DateTime and it's offset from UTC. And then we have zoned DateTime, which is, here is a local date and time in a particular time zone. And just in case that would be ambiguous because of daylight saving changes and things, it also knows it's offset from UTC. And those are, in my view, the useful abstractions. And that's for DateTime. We then have a local date, which is, hey, I'm just a date. I don't have any time associated with myself, because that's a useful abstraction, as is local time, which is just a time of day, and time of day would have been potentially a better name for it. And NodaTime has loads of types, basically. It takes the view that if you know what type of information you're working with, then you can expose the right operations for working with that data and avoid people doing exactly the wrong thing. So that makes it harder to use NodaTime than to use DateTime, because if you've got a DateTime, you can kind of do anything with it. That's fine, unless it's the wrong thing. With NodaTime, there are some operations that you need to go via several hops because you're making decisions along the way. So the sort of design mantra of NodaTime, some APIs take a design mantra of don't make the user think about anything. NodaTime goes the opposite direction. It's make the user think about everything, but when they have thought, it pokes you with questions. And when the user has provided the answer to those questions, when the developer has provided the answer, they should be able to express that answer really clearly and concisely. Does that make sense?
That does. That's interesting. And that's probably a good segue to rip apart our source code for
let's go for
the .NET docs.dev. So as I mentioned before, we've got a live share actually open right now with Jon, and we've got some code that we can look at. And I guess I don't even know where to jump in here, but there's certainly bugs. I would like to say I'm very proud of the fact that I did correctly. Well, first of all, I included NodaTime in here, so we have it available to us. But I was for our shows, we were actually persisting our dates as DateTime offsets because we knew the offset and we knew when the shows were going to be scheduled in the future and what that was going to look like. So
let's jump into that to start with.
Yeah.
You say you knew.
I thought I knew.
Right.
Maybe.
And in the US, maybe you do. I don't know how far ahead you plan your shows, but suppose, and these are global shows. So when you've got an offset, is that the offset for you, the hosts? Because if we looked at the offset for me, that's going to be different to your offset, right?
Yeah. So we kind of did some terrible things, and we're in the central time zone, central, US / central. So we've got a DateTime service that knows that it's pertinent to central time, and every time we would instantiate a show, we would look at what the projected offset will be for that date, and then associate it to a set time.
Okay, so that's fine. You had the answer to the question. This is a good thing. If the answer is, I hadn't really thought about that. Like, well, you've got information that's coming from somewhere magical that you don't know about.
Right.
So suppose that you got really far ahead and you were planning shows for 2024. Okay, so you plan one for September the 9th in 2024. And what's your offset now? -4?
-5.
I'd say it's 5 or 6.
5 or 6. Yeah.
Oh yeah. Okay, so it'd be -5 at the moment because of summertime. Yeah. Okay. Right. So that's fine, and you've got all of that in your database. And then the government says, maybe in early 2021, okay, we're going to not observe, we're abandoning daylight saving time from 2023. You've got 2 whole years to implement this. Now what's in your database?
A problem.
Right. And it's because you believe now that you can predict what the offset will be. If you want it to be so I'm struggling to do the math. So it's 12 noon when we started for you, yeah?
11.
Actually. Sorry. Right. Okay. Yep. Sorry. I was then forgetting my own offset. Okay. So suppose your real data is you want to start the show at 11 o'clock Central Time. That much, as obviously you can't tell whether you might want to change your mind about that, but that's really a different thing.
Right.
Your source of truth is you want it to be 11 o'clock Central Time.
Yep.
So I would argue that's what you should store in the database.
11 Central.
11 and Central. And you can add some derived column saying, well, currently I believe that will be with an offset of -5, and that makes it easy to sort things and all kinds of stuff. But then if things change in the real world around laws and daylight saving time and things, then you can just say, hey, I will recompute all my derived information with the new time zone database, and my golden source of truth, which was 11 o'clock Central Time, that's still good. That information is still valid. And so what you've effectively done is the same. The always store things in UTC is exactly the same problem, has exactly the same problem, because it's assuming that you can predict things in the future, which can change. Now, in most countries, we do get a fair amount of time, a fair amount of warning when daylight saving time rules change. I'm not saying, when I talk about rules changing, I'm not saying our normal twice yearly thing. I'm saying like was it 2005 Energy Act, where the rules in the US, you moved by a fortnight at the start and end of the year, as it were, or abandoning daylight saving time altogether. Those are changes to the rules rather than when the rules say that you should switch offset. So in most countries, you get a reasonable amount of warning. Sometimes not so much. Sometimes governments will say, we were meant to have a daylight saving time change tomorrow. We're not going to anymore.
So that's really interesting. So
it's just horrific.
So it's about basically expressing your intent for a specific time on a specific day, without the assumption of the rules potentially changing under. So so in our app, we have the ability for people to like add a Google Calendar, reminder for future shows. How would that be impacted, right? So if we say, to your example, we're scheduling all the way out into 2024, and then all of a sudden we change how the rules are done. So what happens to that calendar invite?
So that's interesting. I can't remember, and I should, because this was what got me into all of this, was working on Google Calendar Sync for iPhones using Active Sync protocols and things. That was my first task at my first project in Google. Got me into all kinds of interesting things. If the calendar reminder says this is that the event is at 11 a.m. Central Time, I would hope that would do the right thing. I don't know enough about the Google Calendar implementation, and it may well be different for Exchange and for Outlook and name your calendar system here. And it's a non-trivial problem, because the other thing you might want to store in your database as sort of semi-derived data is the version of time zone data that you were using, so that you know whether you've got to recompute things. And there's all kinds of subtleties. And hey, you're saying the central time zone. Do you really mean that? Or do you mean in the town in which you are currently? Because, hey, that could change which time zone it's in. There are places in the world, time zones are geographical entities. They are saying this area all has the same time zone ID, because for all of the past and all of the future that we can predict, you have the same time on your watch. Well, if a country has a civil war, splits in two, and they decide to observe different times, then your old time zone ID may well not be right anymore. So maybe you shouldn't store the time zone, you should store a lat long, and then look up what time zone does that lat long represent.
I see where you're getting with that.
Work out the limits.
Right.
How far down the rabbit hole do you want to go?
And out of curiosity, then, so like with our show, we've got the reminder. It says, -5 GMT here, Central Time Zone, Chicago. I think it makes sense what you're saying, but I was going to go back to the actual code here. And so we've got Central Time Zone here as a time zone that we kind of cherry pick out, and we walk up to the time zone info. We find the system.
I hadn't seen that code before. No, just no.
Don't do that.
Anytime. Yeah. So, well, and
this is live share. You can type here, just so you know.
Yeah.
You can...
Okay. Right. Yeah. Let's get in here. So I'm just all of this code needs to go. And no, in fact, let's still have the what's calling this, because it just needs to stop. Time zone info. Time zone info knows what to do. It's got all the information, and it can do it properly. So yeah, I don't know whether in CodeShare I'll be able to see the errors for. Okay, there we go. In DateTime service. So this is wrong, and that's fine. So we have the central time zone. So all we need is, I think it may be a static method for some bizarre reason. Convert. Come on.
There's a suggestion in the chat here that we do a control A backspace in this entire file.
It's not a bad idea. I did write this with little sleep, late hours of the evening. But this is entertaining. Right. We're learning.
Yes. So this is where my relatively poor knowledge of time zone info is going to do the wrong thing. So your date time offset. So what is this date time offset? In fact, why have we got something of adjust for daylight savings?
Where are you at? Should I follow you?
I am in get segmented shows. And it's got this adjust for daylight saving time.
How do I follow him, Cam? Is there a button for that in live share? Follow, focus.
Yes.
I think
in Visual Studio proper, I'm not sure.
So
Oh
in
God!
the top right, just sort of
Click on
near
you.
Okay,
Exactly. We're following you now. We're there.
Okay, so right. So this result.hours add hours 1 is also making an assumption. You've made various assumptions.
Oh yeah, I made lots here. Oh God,
Oh.
I didn't think we were going to get into this fun stuff.
That's fine. And what is this doing? If it's 10, then add.
Oh yeah, this oof. I kind of wish we weren't doing this show now. So now I'm really embarrassed.
No, please don't. So
no. So this is the hour. So our shows, we have this terrible assumption that we're always going to be at 11 a.m. So if for whatever reason it ended up being 10, I was going to add an hour because we want it to be 11 because math.
So the good thing is DateTime offset. I don't know where the DateTime offset has come from.
Adjust right there. Oh God! And then now you're going to open up another can of worms. Feeble
this
attempt.
Is good.
This is
good. Let's see where he goes with this.
So this is my feeble attempt at engineering and algorithms. So I've got this scheduled shows, and I written an extension method called interleave with adapter. And what it does is essentially looks at all of these shows, and you can provide to it different predicates to kind of interleave in placeholder shows, because what we did was on the site, shows that weren't or dates that were available for people to sign up for, we would plop them in as placeholders and let people on the site request to be a guest on them.
Right. So you've already got a DateTime offset here. I would expect that to just be correct. And in particular, if you add an hour, that suggests that your original DateTime offset was just the wrong. It suggests you've got a problem with whatever's creating the original DateTime offset, and you're adjusting it by saying, I'll make it an hour later, not saying I will adjust for my time zone being an hour later, but you're changing literally when it happens as far as the world is concerned.
Right.
So I would hope that we could do this and get rid of adjust for daylight saving time. And basic rule of thumb here, if you find yourself writing anything like the methods that I have already deleted that needs to know, is this thing in daylight saving time or not? It's tricky. That's a bad sign, because it means that you shouldn't be having to do that work. I have to do that work in NodaTime so that you don't have to do it. And likewise, time zone info is, I can pick it apart in various different ways, but it's basically, if you're not using NodaTime, time zone info is your friend. Lean on it heavily and lean on it all the way. So if you want to find the offset from UTC, this is just for purposes of demonstration. So we've got this central time zone dot get UTC offset, and hopefully we can pass that in a DateTime offset. Yeah. So you remember your method that was trying to find the UTC offset for a particular DateTime offset?
Right. Yeah.
That's already there. You don't need to write that code at all, and you shouldn't, because you may have made a mistake.
I probably have. I introduced bugs.
Know. I deleted that code before reviewing it carefully because I knew that it shouldn't be there. You see what I mean? Why really care if that code shouldn't be there?
But so this is all just like the standard BCL DateTime. What would you do with NodaTime instead to simplify all of? Like, does NodaTime just rewrite all of my stuff for me?
Well, you would have to rewrite it all to use NodaTime. I would hope that most of it. So instead of public time zone info, you would have public, and it could be static, probably date time zone central. So we have different providers in NodaTime,
and they're static.
Yep. So there is DateTime providers.tzdb. and you could use that. And I believe it's America/Chicago. In fact, yes, you've got that later on. So I'll assume that's correct. So that's how you would get at it that's using the version that the time zone data that comes within NodaTime. Now, I've talked about how the rules can change over time. So you might want to take either the provider or a date time zone in as a dependency here. And that's probably what I would do. And I can see that we've only got 10 minutes left. So I want to make one really, really important point. I don't think you've got now anywhere here, which is good. But suppose, do you think, you know this code better than I do. If I find now, is it going to find anything?
Dot now, like, or dot
Yeah.
UTC. Probably,
Yeah.
Yes.
If you have that is untestable code.
Right.
So what I would highly, highly encourage, and you can do this with the BCL as well, but you'll have to write it yourself, is the idea of an iClock.
Right.
That you then inject as any other dependency. And given that we've got NodaTime, I'd expect this to be highlighted. Oh, it does know it. It's just Visual Studio isn't coloring it properly at the moment. And then you can use clock to say, hey, what do you believe the current date and time is? And then you can write tests that say, right, I will see what happens if I schedule a show and it turns out that that's in that's some ambiguous time. So maybe the rules for Central Time change so that the clocks go back at 11:30 in the morning.
Right.
So 11 o'clock in the morning happens twice. At that point, well, when you try to find the UTC offset, or convert from a local representation to, hey, what does this look like in the Central Time Zone? It would say, I can't. I don't know what you mean because there are two of them.
Right.
And there are things you can do about that, but you can write tests for it really easily. And so iClock is the NodaTime interface, but anyone can write their own. And in fact, I could easily add new file. And let's just make this an internal. I think I've broken things by doing a find, which is kind of.
Oh, you're good. The code, you can't break something that was broken already.
Oh. Let's do add new. Oh, I can only add just file in general. I can't add a specific. Oh, there we go. Okay. So if we have iClock.cs. Okay. And so that's all I would suggest putting, and then you can have public class system clock implements iClock, and yeah, because it thinks it was a text file at some point, so I've got no IntelliSense, but it's fine.
Where is that at? I don't even know where your text file is.
It's that's interesting. It's
I put it in the repositories. Okay, but
yeah.
it says it's a CS.
There we go. Yes, I've got one called newfile1.txt that.
The joys of live share. Yeah,
absolutely.
That's what I'm blaming it on.
Hey,
that's actually consistent with the behavior Cam and I see in the VS Code live share, where if new files are added, it sort of confuses live share at times.
Well, it confused all of us as well.
So, I could make this a singleton. So. That's all you need to do to make this testable.
Right.
And then you have we have a NodaTime.testing package that has a fake clock, but you can either tell it an original, and then we can just do
This is awesome. So we've got 5 minutes while you're finished typing this up here. Let's have some kind of closing thoughts about why this code is terrible and why to use NodaTime.
No, actually, that's a great thing that we should close with, David. So if you're looking at the canned DateTime APIs provided by .NET, what questions would you ask yourself to determine whether it's time to use DateTime or just try and work things out with the standard DateTime APIs?
I would ask yourself how much you're actually interacting with the dates and times. If you're primarily just storing them and then returning them later on, never doing any manipulation at all, do you ever need to ask yourself what is a month from now, a day from now, what is the time zone offset? Any questions around that? If the answer is no, you've got a timestamp and that's all it is, and maybe you need to see, is that after or before now? I would definitely go with the introduce an iClock interface and then make your code testable. Great. But DateTime probably won't get you very much. If you are ever manipulating dates, if you ever work with time zones at all, then I think you should at least look at DateTime, because if you look at the design of it, you can say, hey, okay, I don't want to go through all the hassle of porting my code to it, but I can use the ideas and the abstractions as a way of naming my variables, writing my documentation. If everyone on the team knows DateTime, even if you're not using it, then you can all communicate using the same terminology. And just that, I think, is a big win. Otherwise, you see something that says DateTime and you think, well, I really don't know what to expect from that. Whereas if you have a DateTime offset called instant, then I would assume, okay, I don't really care what the offset is. I just care that I know about the instant in time that it represents. For example, if I have a DateTime value called local DateTime, I would perhaps paradoxically, and you need to talk to your team about this, expect that to have a kind of unspecified. Not local, because DateTime.kind of local should almost always be avoided, unless you're writing sort of really genuinely local WPF, WinForms app or whatever. Sometimes that can be useful. But if you've got this terminology, then you can say, I know that if I ever need to do a conversion, if I want to find out what instant in time that represents, then I need to do a time zone conversion because I've only got the local version. And that sort of it ties in with that design philosophy of know what questions you need to ask yourself. Ask them. If you're reading a requirements document and it says, I will ask the user what date and time they want something to happen at. It's like, okay, there's about 15 different questions you need to ask there and really get nailed down in the requirements. And again, it comes back to the blog post about, UTC is not a silver bullet and what you should store in the database. If you store what the user tells you and you've asked the user the right questions, then everything else should follow. If you store, okay, the user said this, but I know better than the user, so I will derive some data and then whatever. It's a bit like saying, okay, the user has entered an integer, I will square it and store that square value, and I can always get back to what the user typed. Well, no, you don't know whether 49 came from -7 or 7. So, why not just store what the user gave you? Most databases, we're not running short on storage space. So in some ways, storing UTC and assuming that you can reverse it later on is a little bit like the year 2000 problem all over again. Doing that because, I'll save some space that way. No, store the local value, store the time zone that you believe the user is in, or their location or whatever, and then derive whatever data you need to actually use it. But that's your source of truth.
That's a awesome recap. This has been an amazing episode. Thank you so much, Jon, for coming on today and joining us for the special edition of the .NET Doc Show. I know I've got a lot of cleanup to do here, so I'll probably be asking questions on Stack Overflow, which you'll be answering. So thank you for that.
Absolutely. Thank you.
I'd like to say, for everyone in the U.S. who's viewing today, happy holidays. So it is Labor Day here in the States. Thank you for tuning in during the holiday. And then, Jon, one request for you. We just ask that you hang on for a bit after the stream so we can wrap up the show with you.
Absolutely.
Thank you, everyone.